It's going.
Yay. Okay, so this is an experiment. We'll see how this video goes. It may or may not ever make air. Anyway, I'm Mark, and my son is holding the camera, and we're going to try to make a video. So this is the shop. We do metalwork, woodwork, electronics, and a variety of other hobbies and pastimes and activities that we may or may not have a lifetime to get onto video, but we're going to start somewhere. So we're going to start with probably the rebuilding of a Bridgeport. I picked up a Bridgeport milling machine, your classic Series 1 J-head, about a year and a half ago, and putting it back together we discovered that it had a little too much slop for my liking. So after a lot of searching, I'm trying to find a machine shop that could plane it in, get some of the belly out of the ways. We've discovered that basically nobody does this anymore, and if they do, it's going to cost you far more than the machine is worth to have it machined. So the alternatives left to us are to look for another Bridgeport or to scrape it in ourselves. It's a lot to scrape in. Well, we'll go over that in a minute. Anyway, so this is the shop. I think Joe is going to pan around and show you the shop. This is the woodworking side over there. There's table saws and band saws and jig saws, sanders. The bench over there has the press and over there. The bench over there has a tapping machine and a kiln for heat treating tooling. Annealing, all that sort of stuff. So moving on. So this is my 11-inch Sheldon. It's currently outfitted with a faceplate because we were doing some turning between centers of some. Where is it? Oh, it's over here. We were turning some Chinese junk instrument holding devices, trying to turn a Salzier into a silk purse, and I can assure you that we have greatly improved upon it. It is now a Salzier with a nice finish. It's still junk, but that's not always the case. We often do make some pretty nice tooling out of starting with some Chinese junk. It just needs to be remachined to proper tolerances, but that's future video material. The very next project that should be done is going to be this. This is a Kingway 24-inch straight edge with a dovetail. It's been heat treated, stress relieved, and it needs to be machined. And we started doing some scraping here just to get a feel for our new scraper, which we'll show you momentarily. This is going to be probably just fly cut on a milling machine before I do any more scraping. To scrape this in from this condition to a final finish would be torture. So we're not going to do that. Okay. So here we have our Bridgeport. This is obviously the knee, and we've done some measuring. 6 ways to Sunday. I'll probably in a future video we'll actually get into some of the techniques for measuring this. How do we measure that both of these surfaces are in the same plane when there's this dovetail in between in the way? squareness to the column, and all those kinds of measurements. It's a little tricky. It's interesting, and some people have come up with some novel ways of doing it. There are a couple of books. Anyone interested in doing this work? There is the Machine Scraping and Machine Reconditioning by Connolly, and there's also the Moore book, M-O-O-R-E, on the foundations of mechanical accuracy. And both excellent books. They can be gotten on Amazon. They can be downloaded from Scribd and probably a number of other places. So anybody's interested in this. This was my first scraping tool. It's a piece of carbide. It's a square flat piece, obviously, which is not what scraping is normally used, but I did use this to take down some of the burrs and dings on this surface. So I got all the high spots off, and so we can take some measurements. It's hard to take measurements when you've got all these burrs and dings in the machine. I think somebody took delight in dropping heavy objects on the back of this lathe, because there's a lot of dings on in here that needed to be scraped out. But it's fairly smooth now, and I've got about 3/1000. If I slide my little gauge across here, I run about 3/1000 of an inch of wear in the middle of these ways, and various wear on some other components. The column, fortunately, is in pretty good shape. I may not scrape the column at all. Likely I will not. So over here, we have the saddle. Now this is looking at the bottom of the saddle, which sits on those surfaces that you just saw on the knee. There is quite a bit of wear on these. You can see I've already marked this out to 1/1000th of what the approximate height is above this surface. When these are machined, they mill all these surfaces together, and then they scrape these surfaces using this surface, this rough milled surface, as a gauge. So that surface is still available for us to measure against. So that's what these numbers here are. Some of them are worn off, but you can see that I have as much as 10/1000ths difference from one end of the way to the other. So that means the table, if all else being perfect, the table would be tilted forward, given this is 824, this is 836. So here the table would be tilted forward 12/1000ths low in the front, in the y-axis. So that's quite a bit. 12/1000ths is a lot. So a lot of material is going to have to come off of this, and that's going to drop the dovetails deeper. It's going to means that the gibs are going to have to be built up, probably with some sheet brass. Some people use Turkite. I'm planning on using sheet brass between the casting and the way. But all of these will need to be scraped as well. There's significant wear on those. I haven't gauged these up yet, but that'll all be in some future videos. And the preferred tool, coffee. Always got to have coffee. The preferred tool for scraping is the veritable hand scraper. It has a radius to the edge. It's sharpened at a 5-degree angle, typically. Other angles can be used for other purposes. Other radii can definitely be used for smaller scrapes. I'll talk a lot more about scraping as we get into it. This is a machine scraper. This is there's basically two companies that I'm aware of that make machine scrapers. One is the Biax, which is a Swiss company, makes the Biax scraper. It's marketed in the United States from DEPRA in Connecticut. And the other one company, the German company, is Renz, R-E-N-Z. Here's an example of two of the scraper blades. And they come in various thickness spines for flex when you're actually scraping. These are pretty heavy. This one flexes a little more, but only because it's longer. It appears that this is holding a blade similar to this Sandvik. So this actually has a Sandvik type of Sandvik blade in it, piece of carbide. And as soft as cast iron is, and as hard as carbide is, they do get dull pretty quickly. So this is a very small radius blade for making very small scrapes when you're finished scraping, when you're getting down to the end, and you want those very, very small points of contact, and depending on what you're scraping. But this would all be background information that we can discuss later. It's in the book. It's in the Connolly book. It talks all about how many points of contact you want for different types of machine surfaces and work. That's my this is what Santa brought me, scraping tools. And you see the engine in the background. That's some of the things that we do on occasion, is work on engines. We have a Wisconsin out in the barn that's about to get rebuilt. We have several outboards that get restored now and then. My sons do model airplanes and trains and all sorts of other things. So who knows what we'll get into. Welding equipment, obviously. Plasma cutters, and just the general things that you find in any shop to do fabrication and machine work and repair work, and of course the ubiquitous gas turbine. Everybody has a gas turbine in their basement. Mine is a smaller one, but this is actually we joke about this. Someday this may or may not go into a boat. That's what we're hoping. But in the meantime, it sits here as just a lovely conversation piece. Everyone should have one. This is a 1961 T53L1 gas turbine. It's built by Lycoming. It was used down in their Sikorsky facility in not Bridgeport. Where was it? Lordship, Connecticut, and Lordship Boulevard. What the heck was it? Stratton. There it is. Stratton, Connecticut. And this is one of the original designs. It's what they call a free turbine, meaning it has two shafts in it, or one shaft runs the compressor, and the other shaft is other set of blades runs the transmission, the 901 transmission on the end. So it's not a jet. It's it's an engine, more or less, and it develops a little less rated, tiny bit less than 1,000 horsepower, just about 1,000 horsepower. But it will go beyond its rating, as most military stuff will. And this engine never saw flight service that we know of. It was in a laboratory, and it was basically fawned over by gentlemen in white lab coats, and is as perfect as they could make it. This engine was purely for specification testing. Things like blade weight and balance, and measuring oil flow rates and temperature rises and stuff. It never saw anything near destructive forces or any hard service. So this engine should be in really good shape. We have spun it up with external power. We've never ignited it, but it certainly has been ignited. And we've got all the documentation to go along with it, with little notes in the margins and all kinds of interesting little comments. And you know, there's nothing, really very little left to the imagination in this engine. Anyway, it's a T53L1A, and the latest version of this engine is still in flight service in the UE style helicopters. They are now up to a T53L13, I think, which generates a rated, I may be wrong on this, but it's somewhere in the vicinity of 1,500 horsepower. And it's a dual blade free turbine. Has a few other extra features on the outside as far as like de-icing and pressure venting, but not a whole heck of a lot different than this engine. Same footprint, looks the same from the outside pretty much. A little different on the inside. So, but I'm quite happy to have this. And the ones that they put in the Miss Geico speedboat, if any of you are into ocean racing, they have two of these in the Miss Geico, and several other speedboat racers have used T53s as well. And the Miss Geico currently holds the water speed record, I believe, at 210 some miles an hour. Those engines develop well over their rated 1,300 horsepower. I think they're probably running them closer to 15 or 16, and they are quick. They turn propellers with them. We are hoping to turn impellers with them, and the reason being, we don't need to go 210 miles an hour, and if the water intakes for the impellers are, say, amidships, when the bow comes up, they will suck air, and the bow will come back down, rather than having the boat flip. So you'll have a complete loss of thrust as soon as your water intakes come out of the water. And this engine, being a relatively constant speed engine, that's not a problem. It'll lose torque. The fuel system will immediately back off. It'll maintain its RPM, and as soon as that load is put back on the impellers, it will reapply whatever fuel is necessary to maintain speed. It's a very stable system. For a constant speed system like this, it should be a pretty good application. So there you go. Here's our engine. We also do some anodizing, some chemical, some derusting. You've all seen probably a couple of different videos. I know was it Keith? Not Keith. Keith Rucker? Yeah, maybe it's Keith Rucker. I think has done some big derusting baths and in some of his videos, and so we're not going to go there. But that's our kitchen where we do that. And last but not least, if we come this way, it's a little dark in here. We can turn these. If we scan this room a little bit, you'll see electronics, test equipment on one side of the room, and an amateur radio station on the other. I am an amateur radio operator. I will not tell you my call sign. It seems to be the thing to keep one's identity somewhat obscure on the YouTube, so we will follow suit with that as best we can. I'm sure somebody will somewhere along the way figure out who I am. Yeah, you don't want to shoot my diplomas on the wall. we'll edit those out. Background. Who am I? Why am I doing videos? Well, I started my career in electronic engineering and moved into academia and worked on technical support for universities and colleges most of my career. Got another degree in the biological sciences, and now I'm a stay-at-home dad. That's it in a nutshell. And this is what we do. We raise boys and make stuff, and break stuff, and blow things up. My son is smiling. Yes, now he's smiling. Okay. I guess that's about it. So we'll take this back, edit it, see what it looks like, see if it becomes a standalone video, or we're going to add it to something else. We probably won't post this without having something more substantive to follow. Adios.